Azure Cache for Redis helps us ensure that our applications are performing consistently as we manage our web servers. Redis Cache is an open source in-memory caching engine. It provides us with the ability to offer a distributed cache to support your applications. And since it runs in memory, it provides very fast retrieval of your content, which helps improve the performance and scalability of your applications. Azure Cache for Redis is Microsoft's managed service version of Redis Cache. They have dedicated servers that provide full compatibility with the Redis API. It is also worth noting that it can be utilized for resources within Azure or in another location. Let's take a look at how Redis Cache works. We have a pretty simple example here where we've got a user on the left who is making requests to the web app. Behind that web app, we have Redis Cache set up as well as a SQL database. So the user is going to make the request to the web app. The web app will then check the Redis cache to see if the data for the request is present. If it is, it will provide it to the web app and complete the user's request. We're going to say for this example though that the data is not in the cache. So now the web app will need to talk to the SQL database to retrieve the data. This increases the total time for the request because it has to process with the SQL database, and that's going to take longer than retrieving the data from the Redis cache. Once the SQL database provides the data back to the web app, it will then complete the user's request and also add that data to the Redis cache, so it will be available for the next request. In this example, you might be asking yourself, why don't we just increase the memory size of the web app so we don't need to utilize the Redis cache? If you remember, we said it was a distributed cache engine. So as we add multiple web apps, they can all utilize the same Redis cache, so we can have consistent performance regardless of which web app the user reaches. There are 3 different SKUs of Redis cache. All tiers offer encryption and transport, as well as firewall rules, so you can configure and control access to your cache. However, each tier has various performance and features. The first tier is going to be the basic SKU, and this offers a single Redis cache node. It allows you to use from 250 megabytes of cache all the way up to 53 gigabytes. Since it is a single node, Microsoft does not offer an SLA. This would be recommended for a dev test or a non-critical workload. The standard is very familiar to the basic SKU with the exception of that you now have a 2-node cluster. There's a primary replica configuration which is managed by Azure. Since we have 2 nodes, Microsoft does offer an SLA with the standard SKU. They also offer a premium tier which allows you to store up to 1.2 terabytes of data. At this tier, you can get a number of unique features such as georeplication, data persistence, and the availability to import and export data to your cache. This is very useful to ensure your application performs well even after a reboot or maintenance. There are a few different patterns in which we can use to help make the best use of Redis cache. The first is a data cache. With this deployment, we are loading data that is accessed by the application to Redis cache. This most closely resembles the example we showed earlier, where we are caching a subset of data from a database to improve application performance. Content cache is also very similar to our first example, except rather than user data, we're going to be using with more general content. Headers, footers, banners, for example. This content does not frequently change. If we think about the Azure portal, for example, a lot of the screens look very similar, so this would be a great use case for content cache. Session state is commonly used for e-commerce instances. If a user is browsing your website and is adding products to their cart, you may not want that to be permanent, or you may, depending on how much data you're gathering. By keeping that information in cache for their session, you will still have the products in their cart available. So if they come back, they'll be more likely to complete the sale if they don't have to go through and add everything back to their cart again. And then finally, job and message queue. Basically gives you a place to hold data while it's waiting to be processed. If you have a number of tasks that run or a few that take a while, you can write data to the cache and then it will be processed as capacity becomes available.